For problem 4, part A, we just need to take the derivative of the function, and the function here is x cubed plus 2x squared plus x minus 1 all over the square root of x. Now, this function looks relatively complicated, and to differentiate this, though, there's a couple strategies, one of which is clearly better than the other. So one way you could do this is you could just use the quotient rule. That would take a long time, and in this case would end up being relatively complicated. What you could do instead is, since you have 4 different terms in the numerator, you could just divide them each by the denominator and then do it term by term. So in order to do that, what would make it easier is to consider the square root of x as just a 1/2 power and then divide each term. So this is the same thing as having 4 fractions all divided by x to the 1/2. So x cubed divided by x to the 1/2. Remember, every time you're doing this and you're dividing powers, you would just be subtracting 1/2, because when you divide x to a power divided by x to another power, you subtract the exponents. So we can rewrite f of x as, so x to the third minus x to the 1/2 would give us x to the 5/2. This one here would give us 2x to the 3/2. We'd get plus x to the 1/2 minus x to the negative 1/2. So again, this was just dividing each term by x to the 1/2. And now we have 4 different terms, but now we don't have to use any more complicated rule. We can just use the power rule and differentiate each one of these by itself. So that's what we're going to do. So now f prime, our derivative, would just be using the power rule on each one of these. So we'd have 5/2 x to the 3/2. Remember, your power rule says bring the power in front and lower your exponent by 1. So here we would get 3/2 times 2, which would give us 3x to the 1/2. Here we'd get 1/2 x to the negative 1/2. And here our negative exponent would multiply down and make that positive. So we would get plus 1/2 x to the negative 3/2. So you can see here that this is our answer, 4 different terms. And we got that by just dividing each term by our denominator instead of doing the quotient rule. So we could simplify this, though, into 1 fraction pretty simply. We would need to figure out what we're dividing by, or what's going to be on our denominator. But keep in mind, when you have a negative power, that means that term is on the denominator. So here we have an x to the 1/2 on the denominator. Here we have an x to the 3/2 on the denominator. So all of these, if we just made a common denominator, it would be x to the 3/2. So let's rewrite that once more as 1 fraction, where our denominator is x to the 3/2. So if we're creating a denominator of x to the 3/2, our numerator is essentially just what I underlined here times x to the 3/2 on every term, so that when we divide by x to the 3/2, we get this back. That's our idea here. So this would be 5/2. So if we wanted to get x to the 3/2 by dividing x to the something by x to the 3/2, again, we're just multiplying this by x to the 3/2, which when you multiply, you add the powers. So 3/2 plus 3/2 would be x cubed plus 3x squared, following our pattern here, plus 1/2 x plus 1/2, because that one has the power of negative 3/2 already, so it wouldn't have done any of that. And then one more final step we could do is, since we have a bunch of halves up here, we could just put the 2 on the denominator. Again, essentially multiply the numerator and denominator by 2. So if we do that, we get 5x cubed plus 6x squared plus x plus 1. All divided by 2x to the 3/2. And that looks a lot nicer, and that could be our final answer here. So again, when you have a term or a function that has a bunch of terms in the numerator, it makes more sense to divide each one and do it term by term instead of using a rule like quotient rule.
The Teaching Center, UF's Learning Resource Center.